we want to prove that in a primitive Pythagorean triple, and remember, a primitive Pythagorean triple means that A, B, and C have no common factors. So prove that in a primitive Pythagorean triple, A, B, C, either A or B is odd and the other is even. And that C is always odd. So the proof that we're going to do is a proof by contradiction. So what that means is we'll assume that it is false, that either A or B is odd, which means that either both A and B are even or both odd. So case 1, let A and B both be even. Well, if A and B are both even, then A squared and B squared are even, because an even number times an even number is even, and an even number plus an even number is even. So what's going to happen is that then C is also even. So this means that A, B, and C are divisible by 2. So the triple would not be primitive. So we have a contradiction. So the triple would not be primitive. And we arrive at a contradiction. Case 2. Let A and B both be odd. So if A and B are both odd, A squared and B squared are both odd, and an odd number plus an odd number is an even number, so we have now that then C must be even, and there exist numbers m, n, and l such that A is equal to 2m plus 1 because A is odd. B is equal to 2n plus 1 because B is odd. And C is equal to 2 times L. And now we're going to substitute A, B, and C, these expressions for A, B, and C, into the equation A squared plus B squared equals C squared. We will substitute these expressions into A squared plus B squared equals C squared. So again, if we let A equal 2m plus 1 and B equal 2n plus 1 and C equal 2L, then we obtain two m plus 1 the quantity squared plus 2m plus 1 the quantity squared equals 2L the quantity squared. I'll let you take a minute and simplify by expanding and combining like terms. What we end up with is 4m squared plus 4m plus 4n squared plus 4n plus 2 equals 4L squared. Of course, I can divide both sides by 2. We end up with 2 times the quantity m squared plus m plus n squared plus n plus 1 equals 2L squared. So if we assume that A and B are both odd, which forces C to be even, we plug in these expressions for A, B, and C, and we have this equation right here that I put a star by. So look at that equation for a minute. We actually have a contradiction right now, because if we look at the left-hand side, we have an odd number because we have 2 times something plus 1, and the right-hand side is even. So this equation says that an odd number is equal to an even number. So again, we have a contradiction. So we arrived at a contradiction when we assume that A and B are both even and when A and B are both odd. So we have proved that either A or B is odd and the other is even. And from the equation A squared plus B squared is equal to C squared, we see that C is also odd. Now that statement itself can also be proved. That'll be a homework assignment in the near future. So we see that C is also odd. So the statement that we wanted to prove has been proved. The next thing we're going to want to do is actually find a formula that will generate these Pythagorean triples, and that's what is coming up next.